two variable inequalities and systems of inequalities. We're going to graph some inequalities and then list three possible solutions that fall within our graph. So the first inequality I have is y is less than x. Okay, y less than x. Well, let's think about how we would graph this if it was just an equation instead of an inequality. Y equals x, right? So that's like a y equals mx plus b situation. So I could identify the slope in front of my x as 1, and then b, that's my y-intercept, 0, comma b. Since there isn't a number over there, my y-intercept would just be 0, comma 0. So if I go to graph this, I'm going to start at 0, 0, and then I'm going to rise up 1, over 1, up 1, over 1. Now, since this isn't an equation though, it's an inequality, we have to take a few other things in account. Since it's less than and not equal to x, for less than or greater than, what we do is we dash our line to show that we're not equal to it. Then, if it's less than, we actually end up shading our graph, and we'll talk about that in a second. Let's get this line drawn first. Now I have my nice, beautiful line, so now it's time to incorporate the inequality part. So less than, yes, that means I dash my line, but less than is less. So I want to shade what's less than this line I've drawn. So if I have a less than side, I'm going to shade below the line. So what I like to do is I like to go to my line and say, okay, well, below this line can get tricky if my line gets really steep. So what I do is I drag an arrow pointed down off that line so I see where below is. So now I can see, oh, I'm going to shade this whole area to graph y is less than x. So there's the graph of my inequality, but I'm not quite done yet, right? It said then state three possible solutions. So if I'm going to state three possible solutions here, that means I'm stating anything that falls within this shaded region. So I could state, let's see, I could pick some random point right here, this point, or I could pick this random point up here, or I could pick this random point right here. I like to pick simple points if at all possible, but since I've already graphed these are the ones I'm going to pick this time. What if I chose like a solution directly on top of my line? Like what if I chose, I don't know, this solution right here? What is that, 1, 1? Would 1, 1 work? My x coordinates 1, my y coordinates 1. So that would read 1 is less than 1. Is 1 less than 1? No. So because my less than symbol wasn't equal to, my line is dashed, which means I cannot choose a point directly on that line as one of my possible solutions. If it would have been equal to and I had a nice solid line, I totally could have chosen that point. Why don't you go try to graph this next one? Before you draw your graph, let's check to make sure you're gonna draw it correctly. Since I have a greater than or equal to sign this time, I know that my line's going to be solid and it's greater than, so I'm gonna shade above that line. Go for it. Check your graph with my graph. I have a solid line and then I've shaded above it for my greater than. The 3 points I decided to identify were 0, 0, 0, 1, and 0, 2. Again, identify some easy points because you're really choosing them so you could actually check to make sure you shaded in the correct position. So like 0, 1, if I plug in 0 for x and 1 for y, 1 is greater than or equal to 0. So it's just easier for you to check if you choose nice simple points. And then you can see I plotted them on my graph in a different color just so you could see they really do fall into that shaded region. This time it was okay that I chose one on the line because the line was solid, so it was equal to. You do not have to change your points to my points. These are the 3 points I chose. Yours might be different. This one, y is greater than or equal to 2. This one's a little trickier because it doesn't look like that slope-intercept format. So I could almost, I'm just gonna draw a little thought bubble up here, right? Just thinking about it. If the inequality sign throws you off, just think about it as y equals 2, right? Y equals 2. Y equals a constant is just a horizontal line at 2. So just because I have an inequality doesn't mean that's going to change. I'm gonna go to 2 on my y-axis and y greater than or equal to that 2. So I'm gonna have a nice solid horizontal line going across the entire graph. It's greater than, so I'm going to shade above, so I could draw arrows pointed up, and then I'm going to shade that entire region up there and choose 3 points before moving on. Right, check number 4 with my number 4. I shaded below and then really check to make sure you dashed that line because it wasn't equal to it. It was y is less than 2. So we have a dashed line, we shaded below. There's my 3 points that I chose. Your points might be different. Let's try this next one. This time it's x is less than or equal to 2. Weird, we have x's. So let's again have a little thought bubble, x equals 2. If I were to see this, well, x equals 2 is right here, and it's x always equals 2, so that's gonna be a vertical line. Now it's less than or equal to 2. There's no above or below because it's a vertical line, so I can't like draw an arrow pointed up or draw an arrow pointed below because I have a vertical line. So instead I just have to think about it. X is less than or equal to 2. Well, is 1 less than or equal to 2? Yeah. Is 0 less than or equal to 2? Yeah. So it looks like I'm going to need to point this direction, almost as if we were on a number line. So when we have a vertical line, we're going to have it shaded either on either side of that inequality sign. And then here are my 3 points I chose to identify. Remember, yours can be different. As we look at this next one, whoa. Wait a minute. I cannot graph this yet. I need to get it into slope-intercept form so that I can identify that slope and I can identify the intercept that I would start at before I can graph my line. So let's solve for y to get it in slope-intercept form. The only thing that's hanging out with y is this -2 right now, so I'm just gonna quickly divide by -2. Do you have that big alarm going off like I have that big alarm going off? I'm dividing by a negative and this is an inequality, so I have to flip my sign. So it's gonna be y is greater than or equal to this time instead of less than or equal to 1/2, because negative divided by a negative is a positive. So I'm writing it as 1/2 so I can clearly see that slope in front of my x. And then -2 divided by -2 is +1, so I have +1. So now it's easier to see my slope is 1/2 and my y-intercept is 0, 1. So this is what I'm gonna use to graph. And then before I grab my ruler and draw my line, let's make sure we're graphing the right line here. Here's my function I'm graphing. Be careful not to revert back to your original. If this is my function I'm graphing, that's a greater than or equal to symbol. So I know it's gonna be a solid line, and I also know I'm going to shade above that line. So check your graph with mine. I've shaded above. I have that nice solid line because it was greater than or equal to, and then I chose 3 points. Again, tried to choose pretty simple points. How about you try this next one? As you're solving for y, be really careful. You added that 2x to the other side. It's still -y, and now I gotta divide that negative sign off. Everything has to get that negative when I divide it off the y. So alert, I have that alarm going off in my head that I have to flip the sign. So y is now less than -2x minus 1. This is what I'm gonna go graph. It's a less than symbol, so I'm gonna draw a dashed line and I'm gonna shade below. Take a moment to get your graph drawn. Be sure to check that graph, make sure you shaded below, make sure you dashed that line, and as I look, I've identified my 3 solutions. Don't forget to identify those solutions. Okay, this next one, I know you got it. Test yourself, see if you have this down. Don't forget to identify 3 points within your shaded region as your 3 possible solutions. Miss Peart's gonna tag back in and try this next one.
Y greater than or equal to absolute value of x. Well, that's just our parent function with an inequality. Remember, on our parent function, our vertex is at 0, 0, and we know the pattern points of up 1 over 1, up 1 over 1. Pause and think, should this be dashed or solid? Well, it says equal to, so solid. And then greater than, so we draw our little arrows, and in this case, it looks like we're going to shade on the inside of our absolute value graph. Keep in mind that sometimes we shade the outside, but this time, greater than or equal to. What are 3 points that satisfy this inequality? We had the vertex already, so of course I'm going to use that point because it was equal to. Now, if it doesn't equal, then I wouldn't have been able to use the vertex. And then I just picked 2 other points. Were yours like mine, or were they slightly different? Let's look at our next one. Y less than the absolute value of x plus 2. What happens to our parent function when we have x plus 2 inside the absolute value bars? Well, remember, inside opposite. So we're actually going to go to the left 2. So what happens to my vertex? It's at -2, 0, and that's always where we start. Has anything else changed? No, our pattern points will still be the same. From the vertex, up, over, 1, 1, 1, 1. There we go. Should it be dashed or solid? Well, it just says less than, so we better do dash. And then, of course, it says less than. So what do? We kind of write a little arrow showing that it's less than or below. And so that means we'll shade this one outside. And then write 2 other points that satisfy this solution. Oh, wait. Does our vertex satisfy it? Actually, it doesn't. So let's cross that out. That's not part of our solution set. It was necessary to graph like the boundary of our solution set. Pick 3 points that do satisfy this. Next, we see an absolute value with a lot of stuff going on, but that's okay because we are good at these by now, right? We have y equals absolute value of x that has been translated to the right 2 inside opposite and up 5 outside same. Then it has -3 in front. Do you remember what we do with that? Well, the 3, always positive, right? The 3 is a vertical stretch by a factor of 3, and the negative actually tells us that we are reflecting about the horizontal axis. So it sounds like a lot of stuff, but we got this. Let's start with the vertex. That's going to be at 2, 5. From the vertex with a vertical stretch by a factor of 3, I'd be going up 3 over 1, up 3 over 1, but it's also been reflected about the horizontal axis. So an easy way to do that is from the vertex, let's just go down 3 over 1, down 3 over 1. Solid or dashed, and less than. So we're going to shade down inside, in this case, the absolute value graph. Pick some points, try that next one, come back and check with me. Okay, how did you do? I would be really careful just making sure that you have the dashes when you need the dashes, and then pick points that you know for sure lie within the solution set, because we have an infinite amount of solutions. All of the points in that shaded area are solutions. So make it be real obvious. Don't be too tricky where it might be in the not solution set.
Now we're going to graph systems of inequalities. That means when we identify 3 possible solutions, they have to be solutions that satisfy both inequalities in the system. Okay, so I'm going to graph my 2 graphs in different colors. I'm going to use green for this top one. I've graphed this first line. I know that it was a dashed line because it was greater than. I know that I'm going to shade above. So I have my arrows on there, so I'm going to go ahead and shade. It's crucial here that I pick 2 different colors, just like 2 different colors for both of my lines. So I'm gonna shade this one in green because that's the color I drew the line in. Really nice and light, because then when I graph the second one, I'm gonna have another color being shaded, and I wanna be able to clearly see where they overlap. Different color pen now. I am going to graph y is less than or equal to negative x plus 1. So less than or equal to, that's gonna be a solid line, and I'm gonna end up shading below because it's less than or equal to. So my y-intercept is 0, 1. I have a negative slope, a negative 1 over 1. This one's being shaded below, so I could draw down arrows coming off of that graph, and then with a different color, so this line is blue, so I have a blue colored pencil. I'm gonna shade, and I'm gonna kind of actually try to shade going a different direction. So this area over here is where my shading overlaps, so this is gonna be the region I choose my 3 possible solutions from. So remember, your solutions can be different than mine. I'm just gonna try to pick ones that I can clearly see and identify them down here. Now, if I was being a good math student, I would probably pick one of these points to check and make sure I've really shaded the correct area. So I might pick like this one, negative 4, 0. If I plug in negative 4 and 0 to here, I would get 0 is greater than negative 4 plus 2 is negative 2. That works. 0 is greater than negative 2. Okay, then I would plug it into this next one and make sure it works here. So 0 for my y, negative 4 for my x. So it'd be 0 is less than or equal to 4 plus 1. 0 is less than or equal to 5. Yep, that's true as well. So it checks out. How about you go try this next one? Ooh, this one looks kind of funky, right? I have my first graph shaded below, then I have my second graph shaded above, both solid lines. So the overlapping area is this tiny little sliver of graph in between. That looks so weird. So when I want to identify 3 possible solutions, if you can kind of see some points in between, you could totally pick those. I might play it safe and just pick some points directly on the lines. Since they're solid, right, I can choose solutions directly on top of the lines. And then remember, you can always check one of your points to make sure you've shaded the right area. Okay, this next one looks like I am so not ready to graph on this one. I'm gonna have to make sure I can get into slope-intercept form so it's easy for me to graph my intercept and then my slope. So that means my y-intercept's gonna start at 3 halves, so 1.5 right there. Then when I start to count out my slope, I have a positive slope, so I'm gonna rise up 1 and run over 2. Okay, now this is where you want to make sure you're not getting tripped up. This is the line I am graphing. So my sign is the greater than sign. So that means I have a dashed line and I'm going to be shading above it. Don't accidentally revert to your original. All right, now switching colors, I'm going to solve for y on this next inequality. This is a greater than as well, so it's a dashed and shaded above. It looks like my overlapping area is right here, so really try to make sure that overlapping area is obvious so that when you choose 3 points, you're being clear about where your solution region is. So I picked these 3, your 3 might be different, make sure you jot those down. Go try number 18 and come back and check in. Let's check 18. The shaded region should be this part way to the right because the first line I shaded above, the second line I had to shade below. Really watch that second line when you divide off that negative, that inequality sign flips. That's why I'm shading below. And so that intersecting or the overlapping shading happens right here. So there's the 3 points that I chose. Remember, your points could be different. Let's see what we do when we have an absolute value fall into the system.
Systems of inequalities with an absolute value in it, that's amazing. Hey, you already know how to do the systems with lines, and I noticed that that first one is a line. So go ahead and get it into slope-intercept form, and then tune back in if you need any help, but you already know how to graph the parent function. So you could try it too, and then check with me. So there's our line above, and now we have the basic parent function for the absolute value graph. So vertex at 0, 0, and then pattern points from the vertex, up 1 over 1, up 1 over 1. Remember, dashed because it's just greater than, not greater than equal to. How does yours look? Okay, the only thing we have to do now is pick 3 points from the region where they intersect. Are your points in the feasible region? Look at the next problem. This has y less than -3. So remember, that's just your horizontal line, less than -3, and y less than negative absolute value of x. So what does the negative do? That reflects about the horizontal axis. I think you have it. So pause it, do it, check with me in a moment. Look at the solution set. What region is double shaded? Do you have 3 points written? I hope so. And it'd be kind of weird if they all matched mine. But who knows? Maybe we think the same. Y greater than or equal to -2. Well, there's our wonderful horizontal line through -2, cuts through the y-axis, y greater than or equal. So I'm actually going to make a solid line there and shaded up because greater than. Next, we see that absolute value equation, inequality, and we have +3 inside with the x. So we know that it's actually gone to the left 3, but it hasn't gone up or down. So my vertex, always a good idea to write that, is at -3, 0. There is a negative outside in front, which means it's been reflected about the horizontal axis. Go ahead, finish this problem, and come back and check. Both of these were equal to inequality, so solid. And then you'll notice that it's just that little triangle section. Make sure you've made it dark enough that we know you know which section, which region is double shaded. And then picking the points was a little tricky because there aren't that many. Now I specifically used the vertex because it did equal it, and I wanted to use something that was on the line as well because it equaled also. So think about and look at what your choices were and then my choices, not right or wrong, just make sure they're in that region that's double shaded. Okay, I'm feeling super confident. I have a feeling that you did a great job. Check your work, make sure you understand. If you made a little mistake, just learn from it, right? Use that other color. And you know, it was almost therapeutic doing a little coloring today.
Yeah, shading those regions really can just feel good.
It just feels like back to kindergarten a little bit.
All right, guys, we hope you enjoyed this as much as we did.